Okay, so today we're going to take a look at using the SuperSign WB version 3.7.15 for doing white balance calibration. So we'll start with the program open. The LG SuperSign WB supports both serial and network communications for the displays, and it also supports both sensor and camera calibration. Camera calibration requires a paid license for the camera software to actually work with this. So we're going to do sensor calibration. So we'll make sure we click on the sensor calibration tab to enter into the sensor calibration mode, and then we want to add our display. Now normally video calibration is done on video walls, so the white balance that we're going to do here is on a single display to see the steps in the process that you take to do white balance calibration on a single display. First, we're going to add our monitor. Click the plus sign to bring up the device list. In the device list, you can make the decision as to whether you're going to connect to the display via the network or via a serial connection. Let's start with network. And the reason I'm starting with network is because I do like network. I've done multiple calibrations, and it seems like when I do a network calibration, I get a different reading which is higher than the reading I get over serial or RS232C calibration for the display's luminance values. So I'm just going to click Scan Network Monitors because I want to scan for it, and I'm just going to click on the Scan button. And I have a timeout setting, so I can use up to a 10-second timeout during the scan process. So I'll just go ahead and click scan, leave the default timeout as 10 seconds, and wait out my period to see whether or not we find our display. And the display does show up. Its static IP address is 192.168.1.15. MAC address is also shown. Put a check mark in the box and then click on the add to add it to your display, and then done. So now in your display of the software you can actually see our display is being added in. If you look over here in the far left hand corner beside this, you're going to see a display in the background, and I have a sensor attached to it with suction cups. So I'm going to first select my display. I could select it either there. I could select them all or just select this one. So select this one display, and I'm going to go over here to my setting measurement environment and do a simple select my sensor type. In this case I'm using an i1 Display Pro. Our monitor enter pattern is our pattern type, and then standard illuminant D65. Everything except the i1 Display Pro setting, or the sensor type setting, is default. So we want to do a start measurement. As you can see on the left side of the screen, the display went to white screen, and the software is actually doing a measurement function of the display. So once that measurement is completed, we'll want to step down to check the initial value. Now we can document the measurement results of the display. Sometimes it's easier just to look at it and pay attention to your luminance value and color temperature numbers, 366.9299, and then color temperature at 9450. So we'll do a check the initial value, and then press done to proceed on. And as you can see in the log on the bottom of the window, that we are actually talking to the display, the IP port function commands, and in response we're getting back from the display. So once that's completed, nothing changed in that check initial value. So now we want to do a calculation. Our previous calculation showed it at 360 lumens. The calculation, and now it's set it for 350 lumens is going to be the optimal value calculation. This is a 350 nit display. Now we're going to go ahead and do the calibration process. Now that we've measured our display and we know its capabilities, now we're going to go back to the calibration environment, choose our sensor type. Everything else is default. Calibration mode, our luminance, I'm going to set it to 350. And then we're going to leave all the remaining settings as default. And then go down here to the setting UV coordinates and then load optimal value. You're going to notice some change because we did that calculation in previous steps. The next thing we do is just click the Start Calibration button. And you can see from the image of the display, it's going through the sensor adjustments, measurements and adjustments, I should say. Normally, a calibration takes anywhere from 1 to 3 minutes, just depending upon the display. The actual screen will change. It will go bright and dim. It may even exit that function and go back into the test pattern screen. Don't worry about that happening. It's a component of the software test phase. And now that our green bar is completed, calibration has been completed. Now we wanted to shoot for 350 nits. So let's go back and do a start measurement once again. Allow it to go through the measurement process. And we now have a luminance of 355.5372 and 3447. So we can see the actual change that was initiated within the display. Okay, and that was the simple process of display calibration over a network connection. So let's remove this device. And now we're going to add it over a serial connection. So you'll want to make sure that you check and you know what your serial port, COM port is set at. Mine is COM7. So I want to make sure that I change to that. I'm going to have set number 1 as my set ID, and I'm just going to go down and click the add button. And it automatically communicates over the serial port and sees that I have a 43SM5KD, and it's communicating on COM7. So we're done at that point. So here's the interesting thing. Now that we're doing it over serial port, we're going to see a little bit of a difference. So I'm going to select the display that I'm going to communicate with, and I'm going to do a start measurement. Notice the values on your screen. Red gain 192, green gain 192, blue gain 192, backlight at 97, and luminance at 355.5372, color temperature 9447 Kelvin. So let's start our measurement. Now our measurement says that we're at 355.5718 and then 9444 Kelvin. So there was some variation between that sensor and the display being read through serial and the LAN network. Okay. So we can continue on this process, and we could check the initial value once again. We'll go through this process over the RS232 to see what kind of variations we get in the actual calibration. So remember, we're at 355.5718 on luminance and color temperatures at 9444. Let's do that calculation. And so now let's go back to calibration, the calibration environment. Remember, we still want to set our luminance for 350. Optimal value, it did change, the U changed, value changed. So now let's start the calibration process again. So as the process continues calibrating the display and completed, now we can go back and just remeasure our values. 355, 57, 18 for luminance, 94, 44 for color temperature. So let's see what kind of change we get. We went from 94.44 to 42, 355, 56.25 from 57.18. So there was just a slight variation within that RS232 and the LAN. Now if we went back and did it LAN again, LAN would put it back to just about the approximate identical value as the previous values. So that pretty much concludes using the white balance calibration software itself. Some key points to remember when you're setting up the display's video mode settings: set to calibration before doing the calibration process, as well as under that mode, check your advanced settings and make sure that the black level is set for low. If you still have any luminance or contrast variations across displays in a video wall pattern, use the WB or the white balance button on the remote control and manually adjust backlight, and you can change tint. Using the remote control and adjusting contrast, backlight, and brightness can be more effective and an easier way to get the displays to have a more unified image. Thank you for watching and have a great day.